Hello friends, Sabka Namaste. So today in this video we will create a image segmentation or web app, and for the web app we use Streamlit, and you can see we have a multiple models, one on blood cell, car, cracks, leaf disease, person, and pothole. So let me first show you how our web app look like. Okay, so for that we have to use a Streamlit run app.py file. Just click enter. It will automatically open your browser with the Streamlit. Okay, okay, so this is the interface. The default blood model which is selected is of blood cell. Now let me select the image. Let me select this one, open it. This way you will get one button. Just click on this, it will run segmentation part. You get the spinner and you will get the image with segmentation. This blood cells change to red color. Okay, now let me select one different car. Now let me one select image of car for the segmentation. um, Open it again, click on button, wait for the seconds, you will get this type. You can see that tires are segmented with pink color, body will segmented with blue, and windows are segmented with green color. Okay, so this way you can select multiple models and upload the image and just click on this button and you will get the segmented image. Now let me explain the code. Okay, uh, first thing, these are the package which I will use. These are the data for each for segmentation models. You can see blood cell, and each segmentation model have a data like class name, weight name, color sample for each class name, and the model type. You can see that we have a 6 model, and out of 6 model, 2 are trained on DeepLab, 2 are trained on UNet, and 2 are trained on FCN. Okay, now uh, the first line which comes is this one. This is a you can say this is a segmentation function which I will explain you later when it's come to explanation. The first line will be this, where we describe the page configuration. For that you have to use st.set page config, page title, segmentation app, and layout will be byte. You can see that it's representing this line. Okay, segmentation app header. Okay, now, for representing image segmentation using pre-trained models, you have to display the stacks. For that, before that, let me explain you how you can upload this image as a background. This image as a background, this leaf has a background. For that, you have to first fetch the image path, then just to use this get base image function. This will after this it will open the image in a read binary format, and it will encode it in a base 64. It will encode it. Okay, dot decode. You can see that we can get encoded image. After getting the encoded image, you have to just pass it in a css using this st.markdown, and this is css. You can see that style.st.app, and this st.app basically describe the whole web app, and this way you can give the encoded image. This is a css. Okay, and this way you will set the background. After setting the background for the title, you can see this is a title, class title, image segmentation using pre-trained models, and unsafe, allow HTML true. And you can see that we have a class with title, so it's have its css. So this is a css. Let me erase it from here and paste it here for better explanation. See that, see here, first we describe the text. We can say the title using class title, image segmentation using pre-trained model. Okay, after that we will use this st.mark on this division. Okay, for that we use style.title, and this is a css for it. Okay, now we have to use drop down box. You can see this drop down, this choose a model, this drop down button. Okay, for that we will use st.selection, then the text which we want to display, and when we use data dot keys, it will give me this keys pothole, person, leaf disease, cracks, car, blood cell. It will give me this thing. After getting this, we have to convert that into the list format. So we will use list, and you can see that by default, the model which is selected is the first one, means this blood cell. So when I will use this data dot model name, when I passing this model name means the key, when I'm passing this blood cell, because by default the blood cell is a model which is selected, this whole information related to the blood cell model is stored in this model data. You can say model data variable. Now we have to we have to give this uploader to upload the photo. Okay, for that we use st.file uploader, then the text which we want to display, and the type of images which we want to apply, which we want to allow. Okay, then whenever the user upload the image, its uploaded file will get the boolean error, means uploaded file will get the file. Okay, it will not be none. And when it will get a file, this if function, if and the codes under the if will get activated, then we have to open the image. Okay, after getting open the image, you can see the segmented image initial value will be none. I will explain the use of this variable later in the code. Okay, then you can see that in the interface we have a 3 column, then the original image, then the button, and the segmented image. Okay, to display this type of interface, we used st.column, in which column 1, column 2, column 3 describe the column 2 describe the button, column 3 describe the segmented image, column 1 describe the original image. And this 1.21 and 1.2 is the width of each column, and the gap between each column will be large. In column 1, you can see that in column 1 we are uploading the original image. For that we will use st.image, then image using container width will be true, then the caption uploaded image. In column 2, you can see that in column 2 is just a button here. Okay, so to and you can see that initially the margin from the top is of around 2 br in a html. So that's why we use st markdown br 2 br, because it's a margin from the top. After that we will describe the button. st.button run segmentation. It will initialize the button, it will show the button in our in a user interface of web app. After this we have to describe the css. For that we will use st.markdown, then the div.st.button. It will be the css to allow apply the margin from the left. Now whenever the user click on the button, inside the code which is inside the if will get activated, and will get the spinner with segmenting. And to apply this css on this segmented spinner, we will use this. Okay, this css. Now ultimately apply segmentation function get activated, in which we are passing the image and the model data. Okay, so the function which get activated is this one. Okay, and you know that we have models in which 2 are trained on DeepLab, 2 are trained on unit, and 2 are trained on FCN. So according to that only we have to call the function for the segmentation. Okay, let me wrap whole text. Now if suppose model data, you can see I am passing the model data also and the image. So if the model data type you can see this model type, if is FCN, this function get activated, in which we are passing the image, then the model data, and the model data color sample, class names, and a color sample in a and weight name also. Okay, it's important because we have to upload the weights. Okay, and the same way for the deep lab and same way for a unit. If suppose no model type will be there, it will throw the error. Now let me take the example of this segmentation FCN. Okay, so the compiler will come to here, from where from where this function coming. It's coming from the model function model folder. So it will come to this. It will come to this init file, and you can see that where this FCN function coming. You can see it's coming from the FCN folder, then the FCN ResNet 50 Python file, and inside the Python file it's having a segmentation FCN ResNet 50 function. So we will go to segmentation, and see this weights folder basically contain all the pth file, means the weight file. Okay, so FCN ResNet 50 will come to here. Okay, after coming to this here, the compiler will come to this function f segmentation FCN ResNet 50, in which we are passing image, class name, class color, and weights. You can see that in FCN we are passing image, class name, color sample, and the weight name. In the same way we will get that. Okay, Now first thing is that you have to create the model. So this function will come to, the compiler will come to this function in which we are creating the model. You can use app model to see, this way we are importing the FCN ResNet 50 model from here. And you can see that we are just replacing the head, because in model to classify 4 layers of classification head, we are replacing it according to our number of classes. So torch.add and convolution to length class names, kernel size will be 2. This will get the model. Now after getting the model, you have to get first fetch the weight path, which is here. Suppose the default one blood cell, we have to fetch this path. For that we use os.path join, os path directory name, then 2 dot, then weights, and the weight which we are coming, weight name which which we are getting from the function, from here, okay, from this app file. Now after getting this, after getting the weight file, we have to load it. For first we have to create this state dict or dot torch load. After we will use model dot load state dict. We will load the weights file. See here, here is the model without the weight file, without the weights. You can see that's pretrained false means the model without the weights file, without the weights, okay. Just the architecture of the model is there without the weights. Now when we load the weights means the model with the architecture and with the weights file. Now here the model is in a evolution mode, means no training mode, we are just testing the model. So here we apply some transformation which is required, because during test training time we apply some image, we apply some transformation on the images. So testing time, I have at testing time we have to apply it. And the main uh, tr- data augmentation or the pre-processing which we apply on an image is to resize, and it's up to 24 and the two tensor, okay. And after applying the tensor, this unsqueeze basically add one dimension, batch dimension in the image. Okay, why it's important? Because during during training time we pass the images in a batch format. So during testing time it is required to pass the image in a batch format, so we use unsqueeze 0, okay. Now after that we use with the torch no grade, means no gradient will be there, no operation will be there. Then output, here we pass the image, here we just pass the image, and after passing the image we'll get the output, which is a dictionary. And inside the dictionary there is a out key which keep the predictions, okay, of the image. And inside the out key, this is a list of all the this is a list of the predictions. So when we get the we are just passing one image, so we can use 0 index value to get the prediction of first image. Okay, now here just and to draw the segmentation on the image, we have to pass the image, then the output, then a class color, okay. So ultimately the compiler will come to this function, draw segmentation. So for explaining, so let me first explain you some little code so that I can explain you this manual converting the image into segmentation, okay. So first is the transparency is of 0.5. Then toss dot argument max give me the prediction, predicted mask to me, okay. Okay, and then dot cpu basically flow the data from the gpu to the cpu, but right now I am just using a cpu. But if you will use the gpu to flow the data from the GPU to CPU, you will use just dot CPU. And you know that we have converted the image in a tensor format. So the prediction also, this output values also in a tensor format. So we have to convert into numpy. That's why we use here dot numpy here. Okay, now this for the calculation, for this all calculation, I want the image should be in a numpy format. So that's why npr image, this way I convert the image in numpy. And it might be possible that predicted mass is not in the shape of the original image. And during if we do not resize it according to the size of the of the original image, it might be a problem during the segmentation. So to solve this problem, we will resize the predicted mass. For that we have to use image size, will get me the original width and height. After that we will use cp2 dot resize, then pass the image, original width and height, interpolation, near interest, enter nearest, okay. Now after that, what is happening from here, what is happening here till here, okay. I will explain you with the help of the example. So let me come to the help code. Let me first explain you what is this happening here. This you can see that when I print the model, See this. This is last layer, and this last layer contain last layer is fourth one in a classifier. Last layer is a fourth layer. You can see it's a 520 512 is the in channel, and 21 is the out channel. Means its particular pretrained model is trained on 21 classes, but we have to reshape this head according to our number of classes. So we have changed it just to model.classifier 4. Just change it according to our number of classes. Okay. Create model, you can see that by default the value I choose for just for the explanation, I choose 2 here just for the explanation. Means the model which we are training, which we want to train, is on true classes, having or true classes. Now uh, first thing, that how you can fetch the red, green and blue channel from the image. Suppose this is red, this is the image, okay, in an numpy format, and when you want to fetch the red channel from it, right channel from it, just use triple dot comma then 0, you will get right channel. Triple dot 1 will got you will give you the blue channel, and this will you will get a green channel. Now how this values are coming, let me explain you. See this 20 255 1 2 255 1 2 255 3 255 255 3 255 128 64 192 128 64 192 means this entire row, this entire row, not row, entire column, this entire column 255 1 2 255 3 255, this entire column act as a red channel, this second column act as a blue channel, and third column act as a green channel. This will you will fetch the red and green and blue channel from the image. Now I will explain you this whole code. Okay, this what the processing happening here. For that, suppose this is a mask. Suppose this is a mask predicted by the image, predicted by the you can say predicted by the model. But model will not give me 255 value. Okay, so there is no need of this. Instead of 255, it will give me 1, because it will describe all the pixels value. uh, Means this way, this is a predicted mask predicted by the model. Okay, and here one is one you will can one you can assume that is the area where the segmentation has to be performed. Let me repeat my lines. uh, One, in the predicted mask, or suppose there are multiple classes, then one will be there, two will be there, three will means according to number of classes the values will be there. But these values basically describe the segmentation portion, reason in the image, in the original image. This portion, this areas, segmentation area will be represented by this mask values. Now you can say this is the overlay. You can easily say this line here: overlay np0 whose shape and size of image np, and image np is the original image. So that's why I have just capped this, because the original image is also is a 3 by 3 of 3 dimension, means 3 into 3 into 3 into 3 into 3 into 3. Okay, that's why. And you can say we are using np zeros, means all pixels values are 0 here. Now this is letter, this is our image. Now let you can say this is a alpha value 0.5, and suppose I have only one class, okay, which is described by 1, and its class sample value will be 255 255 0. Now when I will print this overlay, let me run it. Okay, say this is overlay which I have printed, you can say this is the overlay of 00 value. Now when I will iterate over the class sample dot item, first value which I get is 1 as a class id, and colors, and the color which I'll get has a list. You can get a color like this. Now this is a class mask is equal to class id, means you can see this, the type of this class mask. Let me, the class mask is as I have printed it. See, this is a class mask. Is a boolean 2D array. When I will use this, mask is equal to class ID, and class ID value is 1 when I iterate over the class sample. So where in a mask, where is 1 in the mask change into true. Okay, and other values where which is not equal to 1 will change to false. And it's basically give what is give it give the value, it give the reasons where the segmentation has to be performed in a boolean form. Okay, in a boolean form. And why there is a need to to convert the mask in a boolean, not convert the mask, to get the boolean to 2D array, boolean 2D array during changes, because in this, when I where I'm passing this class mask, if I just pass the mask, then that's those values 0 1 0 1 will not act as a reason, will act as a index values, and the calculation will be distorted, will not be correct calculation be performed. Okay, that's why we pass the boolean to the array, which give them, suppose let me, this 3 will be representing RGB format. If suppose C value will be 0, I'm talking about the first iteration. You can see that for the first iteration, when I will talking about the 000 comma C will be 0, you will get the red channel will be 0 because whole values are in a 0 format. So assume that will get red channel will be 0. And if suppose the class mask means class mask will be like this form: false true false false true true. Means in, if suppose if this is a 2D array of red channel, this is a class mask, and in this 2D array, according to this line, all the values where the true is there, all the values where true is there will change to color C. And initial color C, when the C value for the first iteration will be 0, means you can see 255. So all the values where true is there in the class mask, and in the overlay, all the values where true is there, it changed to 255. You can see that 255 255 255 according to red channel. And same way for the green channel. But for the blue channel, you can see that last value will be 0. So there is no change in no change in the blue channel. Now after that, we will get the overlay, and you know that how these values are converted: 255 0 255 255 0 255 255. So entire column will act as a fraction of overlay and blue, and this way. Now further calculations, see what is happening in this line. What is happening in this line? Okay, see here I'm using class id is equal to 0 continue, because see, zeroness values are for the background and we don't want to segment that part. Just by That's why I use if class id is equal to 0 0 continue is equal to, then the skip it whole thing. But other things, other calculations remain the same. Okay, so I will explain you that part. You can see this. But don't get confused that here mask is equal to 1 and here is a class mask I am passing, but the things remain the same. You can see that mask is equal to class id, but I am doing it. Okay, I am just here, I have only one class, but here you have a multiple classes. So according to that, we have to give the class mask according to class id. Okay, so I am just here, I'm just for the easiness of the explanation, I do not use class mask. I use mask is equal to 1 because I have only one class for the explanation part. Now what is happening here? See this. Here this is a formula for applying the color on a segmentation with transparency. Okay, so here first is image is equal to image channel, then mask is equal to 1, will generate the class mask with boolean 2D array, and then we multiply it with 1 minus alpha, then plus the overlay. What is happening here? Let me explain this. This is the first thing. So first for the first iteration, I'm just going to first iteration. That's why I apply the break for the first iteration, and then I will, if I c is equal to 0, then I will get a red channel. After getting the red channel, you can easily see that mask is equal to 1, means all the values where true is there, because this generate a boolean 2D array. We have to multiply with 1 and minus alpha, and alpha value will be 0.5, and 1 point minus 1 minus 0.5 will get me 0.5, and 0.5 will be ultimately the half. So you can see that where there is mass is equal to 1, I multiply it with half. So this is a red channel, and when I multiply all the values where the mass is equal to 1, it give me the values like this after multiplication with 1 minus alpha. And see this, uh, true in you can see where is the mask. See here, mask, true is here, true is here, true is here, true is here, means all the these value will change only. So you can see that 0, this value not get changed, this value, oh sorry, true is here, but when you multiply with half, there's nothing change. True is 1 is not here. That's why in mask I am comparing these index value with the mask. Okay, with the mask values. Okay, so according to mask, 1 is not here, 1 is, sorry, 1 is here, 1 is here, 1 is here, and 1 is here, 1 is here, one is here, and one is here in those places, two places. When you multiply with 0 with half, nothing change. 0 multiply with half, nothing change. When in 255 multiply with half, you will change it. 127.5 value will come generate. But for when I'm printing it, just it's normalize the values to 127, and other values remain the same. And true is here also. When you multiply with 128, you will get 128 into half, you will get 64. This way you will get the multiplications. Now same way for I will multiply with alpha only at that places. Mass is equal to 1, and ultimately when I will add that, I get the red channel of the blended image. So same way, then you can see this when I'm adding it, see 0 and plus 255, 255, 127 plus 0, 127, 0 plus 127, 0 plus 120, 127, you will get 127. Then this 64 plus 127, you will get 191. So this way you will get a red channel, and same way you will get the green and blue channel. And when you convert them into in a complete blended image, you will get a complete blended image in numpy format. And same thing is happening here. Okay, so this is a whole thing which is happening. This is a manual conversion of an image from and apply the segmentation on the color on the image with transparency. Okay, after applying it, we get a blended image. After getting it, we have this variable get a variable blended image. Then we are returning the image with segmentation, and the compiler will come to here. I'm talking about the first function. That's why this will get activated, means output get the image with the segmentation, and we are just passing here. This output is a numpy format. Okay, you can see that we are not converting here, we are not converting the whole thing blended image. You can see image dot copy. Okay, but the image is in a blended in an ND format. You can see this blended image ND array. Okay, see now this also you can see this in a numpy array. Okay, so after for returning it returning it during returning time, we have to convert that into the pill format. After returning the pill format, the compiler will come to here. You can say that initial value will be none. Okay, to activate the column 3, the initial value will be none, but when it's get the image with segmentation, this column get activated. And if segmentation image, it means it get the image, so this st.image just represent this way we represent the image in a column 3. Place the image in a column 3, just convert the image in an np array. Okay, segment image. So this line is extra. Either you just pass the output array directly, you get you does not get any error. Okay, just there is no need of here we are just converting the image in np array segment image. But if you this if we cut this line directly and just pass the output, you will does not get any array. And the container will be with, and the caption which we want to display below the image will be segmented output. Now this is just for the FCN, and same thing is for the DeepLabV3 pretrained for number of classes. And okay, resident 50, same code, so nothing is changed. Nothing is changed. The single line is not changed, but just create model function is changed. Other things remain the same. See, just upload the model, order name in channel, class name. Okay, this way you will fetch the model and nothing is changed. Even a single line is not changed. Okay, so what is happening? What is the problem in this line? Segmentation model. Okay. I will later explain this. Okay, so I think our one library is not installed. So Let me install that so that during using that time, let me first activate my virtual environment. Now let me install that particular package. Okay, it's completed. Now let me close all tabs, save it. Now let me run the file, this app.py file. Okay, now we will use all 6 models. Okay, the default is blood cell. I already told you. Now let me select one image of blood cell. Uh, I already give you example of blood cell in cars. So let me select one different model right now. Let me select this cracks. Now let me upload one image of cracks. Something this. Open it. Then run segmentation. First we have to display. It will display the spinner. Then it will generate the segmented image. Okay, so this way it's not segmenting the whole part. It means our model is not trained enough on epochs. Okay, it's not the problem of our manually segmentation. It's a problem of a model which is not trained on particular epoch. Now let me select one different leaf disease. uh, Let me upload image of leaf disease. Leaf, this one, open it. Run segmentation. First it will display the spinner. Then you can see, oh, it's, the segmented color is in green color. Let me change it. Where is leaf disease? Leaf disease, leaf disease. It's let me change it. 255, 255. It's enough now. Let me save it. Then again run the code. Okay. Okay. Now let me select leaf disease again. Again that particular this one. Open it. Run segmentation. Not bad, but probability good. Okay, you can choose different color also for better segmentation. Now let me select one person and image of person for the segmentation. Person, let me choose this one. Open it. Run segmentation. Perfectly segmenting the image. Oh, not image, person. Now pothole. This one, open it. Run segmentation. Okay, so this way our web app is working. Okay, I had explained you each and every line here, how it's working, what it's mean. So the video comes to an end. So please like, share and subscribe. Thanks to all.